Namaste, a hearty welcome for this video number 12. Friends, this is a very interesting session wherein we are going to discuss with you the proof for midpoint theorem and its converse using basic proportionality theorem. Can you think for a while how to prove the midpoint theorem using BPT? Shall we try? Here we go. Okay, first let us consider midpoint theorem. So this is the figure. Observe the figure carefully. So D and E are the midpoints of AB and AC. And we have to show that DE is parallel to BC and DE is half of BC. So we have to use BPT only. Since D is the midpoint of AB, can we say that AD by DB is equal to 1? And similarly AE by EC is also equal to 1 as they are equal by data. So that is the first point. So AD by DB, look at the figure, AD by DB is exactly equal to AE by EC and each of them is equal to 1. Okay, this is because of data. Okay, now you can say that DE has to be parallel to BC. So if AD by DB is equal to AE by EC, can you not immediately conclude that this DE is parallel to BC? The reason being, yes, converse of basic proportionality theorem, which states that if a straight line is drawn in such a way that if it divides the two sides of a triangle proportionally, here it is equal to 1, then the straight line has to be parallel to the third side. So one part we have proved. Now let us prove that this DE, the length of DE is half of BC. How to do this? Any idea? Okay, so shall we consider the ratios like this, friends? The ratio of the sides of this triangle ADE to the ratio of the sides of triangle ABC. You know that this triangle is equiangular to triangle ABC. Therefore, this triangle ADE and triangle ABC are equiangular. Therefore, they are similar. Therefore, can we not say that the three sides of triangle ADE are in proportion to three sides of triangle ABC? Shall we write that? Okay. AD, DE, AE are the sides of the triangle ADE, whereas AB, BC, AC, AB, BC, AC are the corresponding sides of this triangle. So each of these ratios are equal, and in this case it is equal to 1 by 2. Do you know why it is 1 by 2? What is the length of AB? The length of AB is twice AD, you know. Therefore, we say AD upon AB has to be 1 by 2, and the reason for this proportion is, this is called as corollary number 3 to BPT, and this is 1 by 2, it is because of data. Okay, now you consider D by BC is equal to 1 by 2, and upon cross multiplication BC into 1 is BC, 2 into D is 2D. Therefore, the length of BC is double the length of D, which means D is half of BC. So this is the proof for midpoint theorem using basic proportionality theorem, the converse of BPT, as well as the corollary 3 to BPT. Now the time has come to prove the converse of midpoint theorem. We will go to the next slide. Here it is. So some changes are made in the figure. to prove the converse of midpoint theorem. So D is the midpoint of AB and DE is parallel to BC. We need to show that AE and EC are equal. In other words, this is nothing but the midpoint of AC. Okay, shall we start, friends? Okay, what is the first point? AD by DB is equal to 1 because AD and DB are equal since D is the midpoint of AB on account of construction. What else is given? DE is parallel to BC. That is also given in data only. Okay, so this is the midpoint and this is a line parallel to BC. Therefore, can we say that AD by DB is equal to AE by EC is equal to 1? So, you know that this DE is drawn parallel to BC. When D is drawn parallel to BC, definitely AD by DB must be equal to AE by EC. But AD by DB is equal to 1. Therefore, AE by EC should also be equal to 1. The reason being BPT as well as data only. So now on cross multiplication this ratio, we can understand that AE is equal to EC only. So this is nothing but the midpoint of the third side AC. So the converse of midpoint states that if a line is drawn through the midpoint of a side of a triangle parallel to another side, it definitely bisects the third side, and this is the alternate proof for the converse of midpoint theorem. Hence it is proved. So thanks for watching this video number 12. Namaste, friends. I hope you really enjoyed the converse of midpoints theorem and midpoints theorem using BPT only. Namaste. Namaste.